So for today, just a quick reminder, we were adding and subtracting rational expressions. So when we really started, I started off with this, but by now this is like, yeah, Mr. Server, this is too easy. You just times this one by 2, and you times this one by 3 to get a common denominator. And then we stepped it up a notch. Do you remember the kind where they all of a sudden threw in like 3 plus x here, and then you had to get a common denominator? Well, then you'd go like this, and would you please actually do this one? What would be a good common denominator? Well, you got to times by the other denominator. So Mr. W, can you tell me what to multiply by here and here?
2.
Yep, you're going to multiply by 2 in those spots. It's the other denominator, see? Aaliyah, can you tell me what to multiply here and here?
3 plus x.
Yeah, 3 plus x. All right, so that was a typical, these are not super easy, but we got to move on from them because, you know, like we've already done this. And then this and this, which is really 4, right, get added together. And then I have the denominator. I would just leave it like this. Yes, you could distribute it. I wouldn't mark it wrong, but I'd leave it factored like that. And would you please give me the final answer? Something over something. Remember, this and this get added, and this just stays the same, and it goes here. In a moment, I'm going to ask you to compare what you think the answer is with the kid next to you, and it's like x plus 9 over something. It's not the right answer, but something like that. Okay, so pairing you two are going to compare today. Here it's going to be a little group of 1, 2, 3, and then it's the person across from you. In this row, it's super simple because there's a person right across. So these 2 rows just compare straight across. You 3 can compare you 2 and you 2. Go ahead, see if you have the same answer as them. How do you add 3 plus x and 4? Well, you just add the like terms. And the 4 and the 3 make 7. So did you have x plus 7? Raise your hand if you had x plus 7. Good. And on the bottom, you could multiply it out, but I also said you could just leave it alone. So you could have just said 3 plus x times 2. And that's factored, so it's better in my opinion. If you multiplied it out, it would have been 6 plus 2x. And that would have been fine too. And yes, you could put the 2x first and say 2x plus 6, and I would have accepted that too. All right, so that's the hardest kind of the add-subtract kind. Now let's talk about the multiplying and dividing kind. These are actually way easier as long as you can factor. But I'm a little scared about the factoring part for some of you because this alone right here is super hard for some people. That can be factored, and then you can cancel something. See if you're one of the people that gets this or if you're one of the people that still needs help. Simplify that down. If you can factor it, you should. All right, did you see that there was a 2 in here and in here, so the 2 can factor out? I know this is hard for some people, but there was a 2 here and there was a 2 buried in there. So then what's left? X plus 2. How do I know? Because look, if I go this times this, I get 2x, and I go this times this, and I get 4. See? And then the 2 on the bottom can cancel. Final answer, x plus 2. Raise your hand if you had it right. Okay, good. So, how did they get more complicated? Well, they can get way more complicated. X plus 3 over 4 over 2 plus x over 4. That's a fraction divided by a fraction. That's right off of my basic 20. Fraction over fraction. Do you know how to handle fraction over fraction? All right. I'm going to leave the individual unnamed, but there's somebody who's got their phone accessible, like where they can grab it easily. Please put it in your backpack. I'm not going to say who you are, but if you subtly slip it in your backpack, we won't have any problems. All right. Aben, can you tell me how you handle a fraction like this over a fraction like this? Generally, what do you do to that thing again?
Don't remember entirely, but the denominator.
Yeah, the denominator does something. You change it to times.
Times by the denominator.
And do I just change this to 2/3? No, this is really close to right, but what do I have to do different? You remember? You have to flip that. So it's 3 over 2. So, moral of the story, when we have a more complicated one, it's the same deal. We're going to times by, and then we're going to flip the bottom fraction over. And did you notice that something cancels really nice? See what happened there? The bottom became the top and the top became the bottom. Okay. And did you notice that those 4s are ripe for the canceling? How many of you canceled off the 4s? Yay. Then you're done. A lot of people think you can cancel those x's. You cannot. Do you know why you can't cancel the x's? Because they're part of an add problem. Let me show you that with numbers. It's like 2 plus 3 over 3. Why can't I cancel those 3's? Because that 3 on the top is part of an add problem. Otherwise, 5 over 3, if I cancel that, would just be 2. We know 5 over 3 is not 2. You can't just do this. That doesn't cancel. Why? Because one of them's part of an add problem. If it had been 2 times 3 over 3, then you could cancel it. Because this is like 6 divided by 3, and what is 6 divided by 3? It's 2. See? You can cancel that kind. So why can I cancel this? Because it's a part of a times problem, and that's called factored. See, the 2 times 3 is factored. And if you can factor it, you should. So important, I got a wall sign for it. Okay, so what are we doing now? What we're doing now is taking our rational expressions like this and we are graphing them. These are all rational expressions. That's a rational, this is a rational, and this is a rational. Technically, here's the definition. But I just like to remind you that rational numbers can be written as fractions. So, these are just functions that have fractions in them. That's what rational functions are. They just have fractions in them. They call it a ratio, but I just say it's a fraction function. So what might the graph of one of these things look like? Well, this is the simplest of them all. This one. And I know you probably have never seen this graph before in your life, but I have something that I keep saying, and you didn't have me first semester, so you didn't learn this. I don't think anybody in this hour had me first semester. And so you never heard me say this, but the XY chart is your best friend in graphing, because you may not know what the thing looks like at all, but do you get, if I can get like 6 dots, and I can like find the 6 dots and just connect the dots, I'll know where the graph is. You just get a bunch of dots, and it's easy to tell what the graph is. All right, so I'd like you to put in x is 1 and -1 and 2 and -2. I'm gonna pause for a second. So if the whole point is to put a 1 in, where are you gonna put it in? You're gonna put it there. And then read it. Y equals 1 over 1. So y equals 1. So x was 1 and y is 1. Isn't that a point? 1 comma 1? It sure is. Everybody put a dot at 1 comma 1. We just need to find a bunch of points and then play connect the dot. This isn't that hard. It really isn't. Honestly, graphing to your level and even in pre-calc, all you have to do is find about 6 dots and then connect the dots. It's really not that hard. So can you find 6 dots? So there's one of them. Everybody put in -1 now. So I guess there's this negative now. So Christian, what is 1 divided by -1? -1. So -1 gives you -1. And if I was going to graph that, it goes right here. Let's just keep getting more dots. When you put in 2, Blaine, what did you get when you put in a 2 for x?
I got, for 2, I got 2x and...
It's just x is 2, yes. And then what is the y? Just read exactly what you see right here.
1.
That's not 1.
Oh, 1/2.
1/2. There you go. How am I supposed to graph 2 comma 1/2? Well, you just find 2. This is where 2 is. Comma 1/2 means you go down, no wait, up a half. That's right there. We just need more dots, and then you'll see where this thing is going. -2. Well, that's pretty darn close to the same thing. It's just that. So then it's -1/2. -2 comma -1/2. This is where -2 is. -1/2 is right there. We just need more dots. All right, so everybody put in 3 and -3 and 4 and -4. Sorry, I just wrote that funny. 3 and -3 and 4 and -4. We now have 4 points. We're about to have 8 points. Once we have 8 points, I think it'll become kind of obvious what the graph looks like, but you'll see. So we're putting in a 3. You go back to the original, you put in a 3. And all of a sudden, there's a fraction. When I put in x was 3, I got y equals 1 over 3, which is y equals 1/3. 3 comma 1/3. I'm going to graph that. It goes over 3 and up 1/3. It's just a little lower than that last point. Do you see what's going to happen? If you put in 4, you're going to get 1/4. If you put in 5, you're going to get 1/5. And it just gets closer and closer to that line. All right. So -3 made -1/3. 4 made 1/4. -4 made -1/4. And now I need one more point to really cap this off. I now have 8 points. You'd think I have enough, but after I've done graphing this one, I'm not going to make you have 8 points every time. I'm just trying to showing you how this works. Everybody please put a 1/2 right here. You're putting in x is 1/2. This is a critical one. And this makes your head hurt a little bit. 1 divided by a half. Did you know that whenever you have 1 over a fraction, the answer is just flip it and multiply? Do you remember that from just a second ago? You take the bottom and you flip it and you multiply. Do you get that that's actually 2? 1 over 1/2 is 2. It's like 1 cookie and you're dividing it into half cookies, and you will have 2 half cookies. So y equals 2. When I put in a half, I got 2. So 1/2 comma 2. I'm going to make a dot for that. I'm going to go over a half, that's like this, and then I'm going to go up 2 and I put a dot there. Oh. Do you get that this is going to get closer and closer and closer to that line but never touch it? All right. That means there's something here. Let's just finish this graph off. You'd get the same thing here and here and here. And I wanted you to have one really nice example of how these look. But from now on, I'm going to be fine with you not having nearly so many points. That's how the graph looks. And it never touches this line. I'm putting a dotted line there. Or this line. It never will get there. It'd be a little bit like this. If I said, start with $10. Now cut it in half. How many do you have? Half of $10. What do you got? $5. We now cut it in half again. What do you got? $2.50. Now cut it in half again. $1.25. Are you ever going to get to 0 if I just say cut it in half again? Cut it in half again. You might get close to 0, but you'll never actually get to 0. That's what asymptotes are like. These dotted lines on the graph, this is your first experience with an asymptote, is like saying, here, I'm going to give you a big pile of pennies. I have my penny collection handy. Nope. I can't find them. That's okay. You can imagine it. Give you this big pile of pennies and say, now take half of them, and then take half of them, and then take half of them. And at the end, you'd be like left with a half a penny, or then half of a half a penny. And there'd still always be something left. You'd never hit 0. See, you never hit 0. On any direction, you never hit 0. All right. So if you want to know what these look like as just kind of a general, like generally, here's how the teachers describe it. We go, here's the graph of y equals 1 over x. It just looks like that and that. Where it goes through 1, 1, because, you know, if I put in 1, y equals 1. And it goes through -1, -1, because I put in -1 in, y will equal -1. But it just gets closer and closer to the asymptotes, which are here and here. That's what this parent graph looks like. It's got 2 parts to it. It's the only graph you've ever been taught that's got 2 distinct parts to it. It's the only graph you've ever been taught where it's got asymptotes. It'd be a little bit like asymptotes again. It's hard to describe to people, but if I said, let's say that you had a swimming pool and somebody pees in your swimming pool. Yeah. Now, do you get, even if you run it through a filter, you're not going to get all of the pee out of there? It's true. It might get down to some really low percent, but then you run it through the filter again and you get it down to a really low percent, but it's always going to be some pee in there. So technically what you have to do is completely empty your pool, wash out your pool, and then put the water back in. It's probably not actually happening very much, but you can't get it to 0 unless you completely wipe the pool down to like empty it all out. Otherwise, you keep filtering it, you get less and less and less, but you'll never get to 0. That's like these asymptotes. They never touch 0. All right, so they get closer and closer and closer, but they will never touch the asymptote. Never touch, never touch, never touch. All right, here's the next part. If I said this function just got moved, you need to remember back to when we learned this in the first semester, and is that to the right 3 or the left 3? Hint, it's on the inside of the function. Did you learn something about that where You don't trust the inside, so if you had to guess, raise your hand for right 3. You are correct. Those of you that took right 3, you were right. This function just got moved right 3 because when it's on the inside, negatives are to the left. Why isn't it to the left? Because you don't trust the inside. You had a whole unit on this, and I know you might have forgotten it, and I know your teacher might have been different than me, but I know they taught you that stuff that's on the inside moves opposite of how you would think. That one moves right 3. But what about stuff on the outside of the function? Let's say there's a plus 4. You can trust the stuff on the outside. So it seems like up 4, and it is up 4. My whole graph would move right 3, and this is up 4. I want you to write this down right here. This example, please write this down for yourself. Because I think if I later change this to like a -5 instead of a plus 4, as long as you have this in your notes, it'll stick better. You'll remember 10% of what I say, but about 60 or so percent of what you write, and like 80% of what you actually practice. Okay, so if you can write it, engages that other part of your brain, more likely to remember this. So do you get, if I change this, well, duh, if I change it to a 5, it moves up 5. But if I change it to a -5, then where's it going to go? Down 5. If I change this to a +3, then when's it going to go? Where is it going to go? Left 3. This would change to left 3. All right, so I'm going to make you a new one. If I change it from a 1 to a 3 on the top, don't stress about where it moves to. But this, it definitely moved it somewhere. Was it left or right? Maybe some of you just need to see a few. How many of you were thinking left 2? You were right. That's correct. What if I put a +7 out here? Is that up or down 7? Up 7. All right. But if you were like, well, how am I actually supposed to graph this? Let's say this was the graphing problem right here. I just made it up out of nowhere. You know what your best friend in graphing is? The XY chart. Do you get, if you get enough dots, you just graph a bajillion dots, you'll find it. Okay. I just want you to make 2 points with me then. Everybody stick in x equals 1. Everybody put in x equals 1. And we'll figure out what point we get. You can pick anything you want. And I on purpose picked a number that would work out kind of nice. I just thought about it for a second. I went, it would be cool if I put in a 1, because then I'll have 3 divided by 3 plus 7. Y equals, so I'm getting this answer right here. Y equals 3 divided by 3, which is 1, plus 7, which is 8. Who had an 8 here? Yay, you win. 1 comma 8 is one of my points. Do you get, I just need to make like a bajillion points. But there's a little faster way, and I want to teach you that now. And this is the last thing I got to teach you, so focus. Wouldn't it be cool if I knew where the asymptotes were and I could just go, oh, there's an asymptote here and there's an asymptote there. And then I just need a couple points here like this, and you can go, it gets closer and closer. See, do you get how it'd be powerful if I knew where the asymptotes were? Let me just show you that one more time. Let's say I'm able to show you a way to know that there's an asymptote here and there's an asymptote here. And then you'd just have to find like 1 point here and 1 point there and go, look at that. This is called asymptotic behavior. It gets closer and closer to the asymptotes. It's kind of like a moth to a flame. Have you ever heard that saying before? Because many of you probably never actually seen this, but if you have a candle on, at night and there's a moth flying around in your house, it'll eventually get closer and closer and closer to the flame, and it's drawn in even though it probably knows only at the last second, oh crap, that's hot, and it burns its wings off and it'll die because it'll actually fly right into the flame because it's just so attracted to the light. And there's like some kind of like deep analogies. Some people are attracted to other people like a moth to a flame, and those people are bad for them. And anyway, okay, so these are attracted to the asymptotes. So if you just get a couple points for me, and then the asymptotes, you can know that it's going to get closer and closer like this and closer like that. I don't need like 17 points. So then I have to just teach you how to find where those asymptotes are. So we've been going 16 minutes, which usually means it's about here where it's really hard to concentrate. But see if you can push through. If I give you this as an example, I'd like you to write a good example for yourself of what the asymptotes are. All right? Give yourself one good example. So write this one down, and then we're going to say there's a horizontal and a vertical asymptote. And it's really easy to get those confused. Do you guys get a horizontal line looks like this? It's like a horizon. You know, like here's the sun rising, and the horizon is going underneath it. If you've never thought of it that way, this is the horizontal. And so that's the horizontal asymptote. I call it the horizontal asymptote because it's y equals. See how I'm trying to tie in the y with the horizontal? Horizontal ones are y equals lines. That one comes from this. That tells you your horizontal asymptote. Y equals -4. There will be a horizontal asymptote right here. So I don't get what you mean, Mr. Server. That means if I'm going to graph it, I'm going to have a horizontal asymptote at -4. It'll be down here at -4. Who wants to take a wild guess what tells me the vertical asymptote? Yes.
Oh, the x plus 2.
The 2, yeah. The 2 has to do with the asymptote. But you got to be careful on the vertical asymptote. You guys know this is a vertical line, right? Okay, so the vertical asymptote goes like this. And those are always x equals things. So I call them zertical asymptotes. What? Because I want to connect the x with the vertical. So it's like I start this with an x. The zertical asymptote in this case is x equals -2. Why is it -2? I thought it was going to be +2 because you can't trust the stuff that's on the inside. That's a theme. Anything that's on the inside does the opposite of what you would think. You would think the asymptote would be at 2. It's not. It's at -2. And you know why? Because when you put a -2 in there, you're dividing by 0. Did you know you're not allowed to divide by 0? Anything divided by 0 doesn't exist. Hence, the asymptote. I'll say that again. -2 makes the asymptote because when I put in -2, do you get I'm taking 1 divided by 0? And if you never tried it on a calculator, it says error. You can't divide by 0. So the -2 makes your asymptote. So the asymptote, this is an abbreviation for asymptote. And this is the vertical, aka the zertical. I'm going to put an X there. Zertical asymptote is x equals -2. So if I'm going to actually put it in, it's not over here. It's at x equals -2. So it's over here. That's where x is -2. Because see, this is where x is -2. And now, if I could just have 2 more points. Like I told you, if you're going to do it this way, where you have the asymptotes, You just need to know a couple points. I bet you anything there's a point that's right about here. And then we'll do this thing through it, you know? And I bet you anything there's a point that's right about there. And then we'll do this thing through it. So how do you get these 2 points? This is the last melon, boys and girls. We're up to 21 minutes, but this is the last thing I have to teach you. How do I get these points? From my XY chart that we started with. We just got to make an XY chart. And if you know kind of where they are, would you agree this kind of is in the neighborhood of -1 comma something? Like -1, maybe -3 or something like that? Well, what happens if I put in a -1? -1 goes right here. 1 divided by 1. See, this whole thing makes 1. 1 divided by 1 makes 1. 1 minus 4, -3. Just like it looked like. That right there was -1, -3. And how about this one? Well, I don't know. Well, it looks like it's maybe they put in like -3 because, you know, like it's past this line. So maybe it's like -3. I'll check. I'm going to put in -3 and see if that's my magical point. I'm going to put in a -3. -3 plus 2 is -1. 1 divided by -1 makes -1 minus 4 makes -5. And there's my 2 magical points. -3, -5. And -1, -3. And then you can just fill in this line and go, oh, I know, it goes like a moth to a flame. It gets closer and closer, but this one will never touch. An actual moth will fly right into the flame and end up killing itself. All right. There, that's how you do them. So let's actually go do some of your worksheet now. Okay, so everybody find the worksheet. If we do a couple together, this won't be that bad. Remember, this is a vertical asymptote. This is a horizontal asymptote. We don't do these angly asymptotes, but they're technically called slant asymptotes or oblique asymptotes, but we don't do those in this level. Horizontal, vertical. X, remember me saying vertical? It's trying to pattern you that the X goes with the vertical, and horizontal, patterning you that the Y goes with horizontal. This is a Y equals line right here. And this is an X equals line that goes up and down like that. All right, so you should be able to tell me the asymptotes. Where do they come from again? And by the way, there's nothing out there. So then there's a 0 out there, isn't there? Even I'm being honest here, could easily forget which one's which. But I know, I'm a math teacher, so I've remembered this is where the vertical comes from. It's whatever makes that 0. What makes that 0? X equals 0. And this, Y equals 0. Those are my asymptotes. X equals 0 is a vertical, as in vertical asymptote. This is X equals 0. I always have to talk myself through it so I don't do it backwards by accident. Vertical is X, vertical, you know. X equals 0 is the line that's right on top of the Y-axis. Kind of counterintuitive. And this one's the Y equals 0 line. And then I just need 2 points. Right there and right there. Connect. Boom, I'm done. That was a lot faster than the first time we graphed that. First time we graphed that, we took like 10, 15 minutes. Yes. Just let me finish. I'm almost done. All right, so on to your actual worksheet. We're not going to actually graph the ones that are in my notes here. Let's just skip right to the worksheet. Vivian, have you already opened it? Okay, read me number 1.
Complete the table, graph, and asymptote equation for each.
All right, read me number 1.
1 over x
1 over x. Yay, that's a nice easy one. And what is the first thing it said? Complete the table? Like XY table?
Yeah.
Okay, so I would put in just a few things. Put in 0, put in 1, put in -1. We don't need too many because we're going to get the asymptotes. The horizontal asymptote and the vertical asymptote. Would you guys agree those are good shortcuts? VA, HA? Horizontal asymptote, vertical asymptote. Have I taught you well enough yet that horizontal means Y, horizontal asymptote? Vertical means X, vertical asymptote. Have I taught you well enough that the verticals come from the bottom here? So what makes this one equal 0? Well, if X equals 0. And that the horizontals, they come from what's on the outside of the fraction, but there's nothing there. So then it's Y equals 0. There's my asymptotes. Y equals 0 and X equals 0. And then I just have to find a few points. If you can't find these, I give up. Just put in a 0. And wait a minute, that's an asymptote. Because anything divided by 0 doesn't work, so that makes an asymptote. Put in a 1. 1 divided by 1 is 1. Put in a -1. It's -1. And then if you graph these little dots and put in your asymptotes, horizontal line, like the horizon, and vertical line, like this, then you can use asymptotic behavior to finish it off and say, it'll be like a moth to a flame. I wish this lesson wasn't so hard, but it is done. And the good part is tomorrow, all I have to do is, not tomorrow. Tomorrow is actually the ACT. And so there's just a little Schoology quiz tomorrow that everybody has to do. And freshmen, it's an async day. That means you officially have to do it or I have to mark you absent tomorrow. So freshmen, since you don't have to come to school, lucky you, you have to just do this little worksheet that I posted for tomorrow. And you have to do it during school hours, okay? That's your only job for my class. And then at the end of the day, I check, did the kid do it? If you do it, then yay, you get the credit for being here, freshman. If you didn't do it, you get marked absent. Do you know that if you are marked absent for enough days, eventually they don't give you credit for the class? Like, you can only have X number of unexcused absences. So don't make this tomorrow. Tomorrow's so easy. Just a little Schoology quiz. Just do it. For async credit for the freshmen that don't have to show up. Sophomores and juniors, you're going to be here, and you have to do it, but you don't have to do it tomorrow because you're going to be busy tomorrow. But it's a Schoology quiz that's part of your homework, so you'll eventually have to do it, and I made it really easy. Like, it's super easy. So, everybody, you may as well just do it tomorrow if you have time. Otherwise, freshmen only have to do it tomorrow. All right, let's move on to problem 2, and I'm not going to make you do all the ones in this worksheet. I need to see it quick to see how many I'm going to have you skip, though. So I figured it out. We're going to do the first one, and then we're going to skip until the back page. So there's a bunch we're going to skip there. But when you get to the back page, we're going to do the rest of the assignment starting there on the back page. So Vivian, can you tell me what the first one on the back page is? It's not really got a number, but like, what's the problem say?
-4 over x.
Okay. If I was going to graph this, there's like 3 parts to it. Your XY chart and your asymptotes. Let me help you with both. This is the first one on the back page. I'm going to put in a 0. And do you get if I put a 0 here, you can't divide by 0. That tells me the asymptote. The asymptote from the bottom, those are called the vertical asymptotes. So the vertical asymptote is that. It's the thing that makes the bottom 0. So it's x equals 0. Verticals are vertical asymptotes. That helps me remember x. X equals 0. It's whatever makes the bottom 0. The horizontal asymptote is whatever's out here on the outside of the fraction, but this has nothing out there. I'm going to put a +0 to remind me. That means the horizontal asymptote is the horizontal asymptote is at 0. And last but not least, stick in a few numbers, like stick in a 1 and see what you get when you put a 1 right here. Stick in a 2, see what you get. Stick in a -1, see what you get. And then to actually graph it, when they're both at 0, it's super easy. You just make your asymptotes like that. And then I just have to graph these points. And then use asymptotic behavior to say it'll just get closer and closer to the asymptotes from there. All right, so I'm going to do this last point. If I stick a 1 in, I got -4 over 1 and down 4. There's a dot down here. And put in 2, and I get -2. Oh, so it's doing this. Asymptotic behavior, see? Here's a couple points I found. Now I'm going to stick in -1. -1 goes here. And I get -4 divided by -1 makes 4. -1, 4. Oh, it's just going to have asymptotic behavior up here then. There you go. That's the first one on the back page. You just have to finish the back page now? I have really made it reasonable. Now it's your job to finish it up. Drop it in the Dropbox. I know, this was a tough lesson, but you know, we're starting off with some really tough things. That means that it will get easier later in the semester. It'll be easier. Trust me, it's coming. And that's all I got for you for today.